This is a code walkthrough of the Pitch Snitch application. We'll focus on the user interface aspect of this application. In particular, we'll be going over .dart file extensions. As a reminder, this is the high-level overview of the Flutter framework that's being used for this application. Again, this walkthrough video will focus on the .dart files that make up the user interface. Note there's a key on the side that indicates what the various symbols in the diagram stand for, and that this YOLO screen.dart actually encompasses this whole box here, which can be seen expanded upon on the following slide. With that, I'll hand things off to the code walkthrough for these aspects of the application.
I'm here to walk you through my 492 project and all the code that I implemented that made it to the final deliverable. So this softball tracker director here is our Flutter application. So when we go into the specific views, I was the person who did all of the UI development. So if we go into the main.dart file, you'll see for every screen, it sends you to the specific screen. So here, if the screen is called camera screen, we go to the YOLO and such for the instruction screen, YOLO video screen. And then I also made a separate file for the setup screen. So this is also a special setup page to navigate through the setup specific screens right here. So I'll go through them one by one. We got the setup value screen, which is going to be the simple 3 inputs here, which is going to be a form field saying enter the specific value. This is going for the max height, this one's for the min height, and this one's for the reference height. And then on submission, we use the provider library to set the max height, min height, and the reference height, and then push us to the camera calibration capture. So we can also see in this provider that I set up, we have setup values, which give us the max, min, reference height that we can save those to. We also later will go through the home plate, the reference height, and the pitcher's mound, and set the average pixel length here. We also have the camera instruction screen, which is going to have expansion tiles, which is a tool used in the widget. We go expandable fab widget, and then expandable stepper, which is a combination of all the expansion tiles. So the first expansion tile, step 1, place the camera, has all the steps here as well as an image. Step 2 is capturing the field. We just place that. This is purely a UI, has no real connection to the camera or anything. It's just stepping through those values. And then I also implemented the setup camera screen to capture these values. So first we start the capture, and this is going to run specific stages, and in between each stage it's going to capture, or it's going to show a prompt saying go to the home plate. It's going to run for 15 seconds and then set the ball coordinates to the home plate value, and then once we get all of them, it's going to use that provider class again to save those 3 points, and then it's going to push the camera to the navigator, which is going to navigate us to the YOLO screen. And here's that countdown seconds. With the countdown at 15, this can be switched if you need the countdown to go higher. This also gets the countdown to display to the screen and gets the title based on the stage of the steps you need to do. And yes, and this also rotates it because we are locking our phone in portrait mode while we're capturing the feed in landscape. So there was a lot of modifications to be made. This can all be done on Windows, even though we ran it on iOS. There was very little UI differences. So yes, and then here is the Ultralytics plugin. So if it was Android, which it never ended up working, but we had the TF-Lite file that I compiled from the original PyTorch file. But what we really used was the .ml model, which is used for iOS specifically, and we added to the local YOLO model, and then inserted it as an object detector, which was later put into the Ultralytics camera preview. And this is going to show where our ball is. It's going to update those ball coordinates right here. and it's going to update those certain coordinates for the home plate, the pitcher's mound, and the reference height that we saw above. But this is going to be the main kind of worker for finding the ball in here. We have a similar thing on YOLO screen. My work on this was going to be the UI changes to output the audio as well as setting the preferred orientations and triggering the illegal. Update bounding box color was not me, that was Soli. I did do the trackball function. So it's going to go through, and then once it's going to have a downward trend count of 3. So that means that there's 3 consecutive points in a row that go downwards from the max height. Then we know what that last height is. We can set it in here and compare it to our provider set values of max height and min height, and either trigger illegal or call it fair. I also did the get height function. It's the simple algebraic calculation of using the average pixel length and comparing the specific ball coordinates to the home plate. You may see that this is going to be indexed at 0 instead of 1, which is usually the y value, but remember we're doing this in portrait mode, so everything is flipped. So the x values become the y values and the y values become the x values. So we use the first index of that coordinates list for the y values. I also did the get data widget. That's going to be the thing up in the top left-hand corner that shows the current height, the YOLO coordinates that are returned, and the max height. That max height was set up in the trackball function. The get height is going to return here. It's going to just call the get height function using the current ball coordinates, and the YOLO is going to just output those ball coordinates directly. Now this is going to be a function to return a widget, so we can go into where the YOLO camera preview widget is made, and we can see that the get data is used in here. Let me quick find it. Yes, so within here, the get data is put on top of the YOLO widget. And then that is what I did for the YOLO camera preview. I also did some buttons that's going to be going from home. It's going to send you just to the basic navigation. And also for all of these as well, the angles have to be changed and modified since we are doing portrait mode. And then the data just sets the state to show data false or show data true, which is going to be used in that get data function where it just returns an empty container if show data is false. So you can trigger that widget on and off. There were some helpful widgets that were also in here that I made. Before, we used to mark an image. So an image marker.dart is still in here because it could be useful in the future. This is going to input an image, and then it's going to detect a tap using a gesture detector, and it's going to turn the coordinates here, the xy of where it tapped it, based on the scale of if you want the image marker to be smaller than the actual image or larger. It's going to transfer this gesture detector's xy to the actual image size, xy. And so that's the main things I did for this project that made it to the final deliverable. Thank you very much.